Hi, hello, welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for continuous encouragement and continuous watching of my videos. Today's topic of interest is pressure. We know that pressure is a force acting per unit area, which is called pressure. In fluids, the hydrostatic pressure is acting. The hydrostatic pressure can be measured by means of some gauges, and we are having different types of pressures in nature. We are living in a common atmosphere, so the pressure at this atmosphere is called as an atmospheric pressure. The atmospheric pressure, that is PATM, is nothing but 101,325 Newton per meter square, or we can say 10.33 meter of H2O and 760 millimeter of mercury. So this we can say that different types of atmospheric pressure. Atmospheric pressure in terms of different meanings here. So this is very important about the fluid pressure. Now the absolute pressure, atmospheric pressure, gauge pressure and vacuum pressure. The difference is clearly illustrated in this diagram. How to know the first we have to clear about the absolute zero. The absolute zero is a complete vacuum. An absolute zero is a complete vacuum where the local atmospheric pressure is here. So this is the pressure we measured at the level of a sea. So here it is commonly noted, that is 101,325 Newton per meter square. So this is the pressure at the sea level. So this value is the atmospheric pressure. So the below the atmospheric pressure we can say it is a vacuum pressure, and the absolute pressure plus vacuum pressure will becomes the local atmospheric pressure. Where the gauge pressure is a positive pressure, this gauge pressure is a positive pressure which it is measured above the atmospheric pressure. So the pressure above the atmospheric pressure, which is called as a gauge pressure, it can be measured using different kinds of instruments. Those instruments we can illustrate in the next slide. So the atmospheric pressure plus the gauge pressure is equal to absolute pressure. The atmospheric pressure plus gauge pressure, which is called absolute pressure. Therefore, the local atmospheric pressure minus vacuum pressure will get an absolute pressure. This is negative absolute pressure. So, I hope you have clear about the different types of pressures. So here we have to know the Pascal law. Whenever we study a pressure in a fluid, we have to know this Pascal's law. What it indicates, it states that the pressure or intensity of the pressure at a point in a static fluid is equal in all direction. So here the live example is a screw jack or a hydraulic jack. With a small amount of a force, say if you can see here, there is a small piston cylinder there and large piston cylinder there. Both are connected by means of a a fluid layer where this small piston is connected, the area is 50 centimeter square, whereas the large pressure cylinder, the area is 350 centimeter square. So here you can see 1000 kg of load is applied. Here 7000 kg is being lifted. So that is the power of a fluid pressure. So with this small amount of force, we can lift a huge amount of force here. That is the indication of the Pascal's law. Here the P or F by A, which is equal to F by A. So it is a small cylinders. So this is the big cylinder. So everywhere the area, the difference of an area, we can easily put it. Okay, we know that pressure is equal to force by area. Therefore, force applied to the area of the small piston is equal to force to be lifted at the area of the big piston. So that is the evidence of the Pascal's law. So how can we remember this Pascal's law? By the name itself. It states that pressure applied in any fluid is same pressure applied in a static fluid is same in all directions, so you can say L as a D, all directions. Pascal. Pascal. Pressure applied in a static fluid is constant in all directions. So that is our remembrance. By means of a Pascal itself, we can make. Okay. Next is next and another law of clearly illustrated the pressure. That is hydrostatic law. The pressure oriented in a fluid at rest. It states that the static law, which states that the rate of increase of pressure in vertically downward direction must be equal to the specific weight of the fluid at the point. So what is the specific weight? Which is the rho g, that is P is equal to specific weight into height. That is, if we want to measure a pressure in this region, we have to calculate the specific weight, that is rho g of the fluid, as well as the column height. So that is the indication of this hydrostatic law. We know that when a column is having several holes, the jet of water, the strong jet of water at the bottommost point, how the whole weight of the fluid is acting at the downward directions. Therefore, the downward hole will have a stronger jet than the other holes. Okay. So the equation is like this. P is equal to rho GH. So the hydrostatic pressure in a column like this. If the column is very low, the pressure is very low. If the column is very high, then the bottom pressure is also very high. Next is the pressure measuring instruments. We have two different types of pressure measuring instruments. One is manometers and another one is mechanical gauges. A simple manometer or a differential manometer, we can say in the manometer types. The mechanical gauges, diaphragm pressure gauge, Bourdon tube pressure gauge, deadweight pressure gauge, bellow type pressure gauges are there. In simple manometer, we can also classify the piezometers, U-tube manometer and single column manometers like that. So the simple piezometer I have explained here. I have not at all touched any other type of the pressure measuring devices, since with the help of the problem itself we can easily notice that. And one thing in the manometers, you have to notice that the pressure at right hand side is equal to pressure at the left hand side. That is our interest. Pressure at the right hand side which is equal to pressure at the left hand side. So if you have here the pressure at the A, that is left hand side, which is equal to a column which is raised from the center, that is rho into G into H. So this is the method of finding pressure using a simple manometers or a U2 manometers. You have to notice this point: the pressure at the right hand side is equal to pressure at the left hand side. So you can calculate the pressure with the help of the devices very easily as well as very quickly in nature. Okay, so the piezometer is a simplest type of a pressure measuring devices which is used to measure a very small pressure. Here the one end of the piezometer, so this is the piezometer, the one end of the piezometer is connected to the pipe where the pressure have to be measured, and another end is open to the atmosphere. And due to the pressure in the pipe, a liquid of column H is raised at the piezometer tube. With the help of the hydrostatic law, P is equal to rho GH, we can find what is the pressure by means of measuring this height. Here the same liquid is getting raised. If we want to measure a huge pressure, we have to do a large height of the fluid of the glass piezometer tube. So that is the major disadvantage of piezometer, why it is used in a small pressure difference, since the height we need to measure, which becomes very small for the smaller pressures, and it will have to be a big height for measuring large pressure. So that is why it is limited up to very small pressures. Even negative pressure we can measure using this piezometer. Okay, so with this I close this session of the pressure. If you have any doubt, please let me know in the comment section. I will put another video about this your doubt on the pressure. And if you have liked the video, please like, share, subscribe the Make Techie for providing a more encouragement for creating these kinds of videos. And I once again I thank you all. Thank you.